Myself, Hemming Sathwara. So let us discuss about today's topic. Today we are discussing about unbiased clipper. So let's see what is clipper. So here we can see this is the chart of clipper. Clipper is divided into two parts. One is unbiased, another one is biased. Unbiased are divided into two types. One is series and parallel. So in this video lecture today, we are going to discuss about only series unbiased clipper. So here series is divided into two parts. One is positive and another one is negative. So another one is parallel, which we are going to discuss our next coming video lectures. So here, what is clipper? Clipper is basically wave shaping circuit which cuts off or clips off positive or negative or both the halves together. So this is known as clipper. So let's discuss about today's outcome. So first we will see about unbiased series clipper, then we will discuss about series positive clipper, and last we are going to discuss about series negative clipper. So start with clippers definition. Diode clipper, it is also known as limiter, is wave shaping circuit that takes the input waveform and cuts off or clips off top half or bottom half or both halves together. So clipper is actually divided into two parts, series and parallel. So clipper is also known as amplitude selectors, or sometimes you may heard about this slicers. So this is clipper. Now what is unbiased clipper? Unbiasing means if there is no DC supply connected in the circuit diagram is known as unbiased. That means you are going to connect only AC input waveform, AC signal, and you will get according to that input signal AC output waveform. So here we are not applying any battery in this circuit diagram, so it is known as unbiased clipper. Now let's start with our first topic, series unbiased clipper. So why we called as series connection? So here if diode is connected in series between input and output port, okay, so here the symbol of diode is represented. Now diodes, this terminal is known as P and this side is known as N. Whenever your P side is connected to the positive of input signal and your N type is connected to the negative of output terminal, so this is known as forward bias, forward region, right? So current always flowing from input to output, plus to minus, so it works in forward bias. Now here we can see in this symbol the first type is N type, which is connected to the positive, but here from this side P type is connected to the negative, so both are dissimilar, so it works in reverse bias. That means it works in reverse bias and it will be open circuited. So here we have to assume that if diode works in forward bias, that means it will become closed loop, and if diode works in reverse bias, that means it becomes open circuited. So here we have seen that the forward bias and reverse bias of this diodes condition. Now let us discuss about flow of current. So here current always flow from this direction. So it means if your diode's direction is input to output, that means it is series connection, right? So here we can see this current direction is input to output, so that means it is in series connection. Now let's start with our first circuit, which is known as series positive clipper. We can also say unbiased series positive clipper. So this circuit diagram is positive clipper. Now we are going to discuss about two different types of cases. Case number one we consider as positive half cycle, and case number two we consider as negative half cycle. So in short, we are going to enter positive waveform and negative waveform in this circuit diagram. According to this waveform, we will get the output. So this is our basic conclusion of this theory. So now from this circuit we can see plus and minus. So we are going to enter waveform in this circuit diagram. So first, this is the positive waveform 0 to pi. So if we entered 0 to pi, this portion in this circuit diagram, that means your current flowing from plus to minus. If your current flowing from plus to minus, at that time your diode works in reverse bias. That means it will be open circuited. So that means if your circuit diagram is open, there is no flow of current, so you will get zero output. So for this we can see here, so output voltage will be 0. So this is the 0 to pi graph. Now this is the case number one for forward biased. Here we can see for positive half cycle. Now let us discuss about for negative half cycle. In negative half cycle, our input is like this. This is our input pi to 2 pi, which we are going to enter into this circuit diagram. If current flow from plus to minus, here we can see polarities are changed because here we are using negative half cycle. So current always flowing from positive to minus, right? So your diode will be in closed loop because it works in forward bias. So positive to minus, if current flow, that your diode works in forward bias, it will be closed circuited. That means whatever you are giving in your input side, you will get same from the output side. So that means pi to 2 pi represented as in our output portion. So this one pi to 2 pi is our output waveform. So this is the series positive clipper. Why it is called as series positive clipper? Because we can see here in output waveform, positive portion of the waveform is clipped off. So that's the reason it is known as series positive clipper. Series means here diode is connected in series. Positive clipper, that means your positive portion of the waveform is going to be clipped off. So this is the unbiased series positive clipper. Next, series negative clipper, unbiased series negative clipper. So here we can see the circuit diagram is little bit changed compared to the previous one because diode's direction is different. So here we are going to discuss about two cases as we discussed earlier. Case number one for positive half cycle and case number two for negative half cycle. So in short, we have to apply here input waveform to this circuit diagram. So let's do it. First, we are going to enter positive waveform 0 to pi. If we entered in this circuit diagram 0 to pi, that means positive waveform, then what will happen? If current flowing from plus to minus according to this polarity, plus to minus, at that time your diode works in forward bias. That means it will be closed loop. If closed loop circuit is there, that means your current will be flow. That means your output will be same as the input, 0 to pi. Now this is the case for positive half cycle. Now let us discuss about for negative half cycle. If we applied negative half cycle, that means your polarity is changed. Here positive and above is negative. So always current flowing from positive to negative. So for negative half cycle, pi to 2 pi, if current flowing from positive to negative, that means your diode works in reverse bias. Reverse bias, that means your diode is open circuited. If it is open circuited, that means no current flow from this circuit diagram. That means your output will be 0. Pi to 2 pi is your output for the negative half cycle. Now let us discuss about series negative clipper. Why it is known as series negative clipper? Series, that means your diode is connected in series between the input and output, and negative clipper, that means your negative portion of the waveform is clipped off. So this is the unbiased series negative clipper. So that's it for today's lecture. Keep learning, keep reading. That's all for today's lecture. Thank you.